Hello, welcome to the presentation and demo of Anomaly Detection with IBM Tealeaf. I am Aleksander Oleszkiewicz, and this session was originally delivered together with Zhang Junwei during the Think 2019 conference in San Francisco. Starting this presentation, I would like to get you behind the closed doors of startups. In the end, the session was delivered in the heart of the Silicon Valley. While there are many types of startups, what they are most known for is disrupting the status quo on the market by introducing new business models and methods for doing things nobody before thought could be done differently. What's worth noting is that new business model is not enough for the success. There must be something more, and this is what I would like to discuss today. Many people are of course trying to discover the secret sauce of triumph delivered by the most known companies, and while this research can go very deep into the details of their businesses, it seems that there are three rather high-level elements of their success. First, they do aim to fulfill a need people really have. They genuinely make life of their customers better, easier, or more enjoyable. However, while the idea might be considered the most important, it seems that it doesn't have to be the differentiating factor for the ultimate success. Simply, most of the ideas, once they go live, can be instantly copied by competitors willing to get their cut of the market you discovered or created as a first company. What turns out to be the thing that separates winners from losers is their ability to analyze and tune the user and customer experience to the level that a person who sees their application or website for the first time is immediately falling in love with its capabilities and the value which the site or application is delivering to that person. People have not only a reason to keep returning to the service, but also they are willing to recommend it to their friends. Interestingly, that key value driver of many applications, as perceived by the users, may be very different to the initial concept of the startup founders. So, how do startups know about this? What is making their users tick? What is really attracting the users to their applications? It turns out that many startups are implementing a so-called growth hacking approach. That basically means that they are turning the marketing into a science versus treating this as an art. They are analyzing and measuring pretty much everything what could be measured in their systems, applications, and websites. They are continuously experimenting with different options, possibilities, flows, and user interfaces, doing A/B testing, ABCD, or other multivariant testing, tracking metrics, comparing the results, and sometimes even changing the way they operate or the key messages they are sending to the market based on those findings, going with the flow, going where the customers are going, often pivoting the company's purpose based on those insights to make sure that they are offering something valuable to their customers, something what will really make the difference in their lives. What might be interesting is to look deeper into the growth hacking approach. Historically, many businesses that were thinking about their customer funnel and milestones were using the chronological approach of the funnel for both understanding their business and for setting their priorities. They were starting with acquisition, then activation of customers, revenue generation, retention, and referral, which was abbreviated to R, for which a term pirate metrics was created. In that, what we can call a traditional approach, the key focus was often on attracting more and more prospects to visit a website or download an application. You can think about that as buying visitors' attention, hoping that the product is good enough to get them engaged. It was very costly because purchasing attention on the internet is not getting any cheaper. It was still assumed that the more of new visitors a company can get, the bigger will be the number of those who will convert to make the first purchase. Then, as in a waterfall, the bigger will be the number of people who will make the second purchase, which is often the moment when a customer is actually starting to be profitable, and then keep returning to the service and will talk about it to others. That sounds great. A waterfall or funnel are great analogies, except that for most businesses they turned out to be pretty inaccurate. It's like you won't be getting more water flowing from a tap by simply adding twice as much water into a water tank, at least as long as the pipe connecting the water tank to the tap remains the same. You cannot push more traffic, more people through your checkout if there are some issues, if this is not wide enough to make or be able to accommodate those increased traffic. Similarly, driving more traffic to website that it's not user-friendly, has issues with functioning, technical glitches, is not optimized. It might often mean that more users would become irritated, they will have bad impression of the company and start spreading the message among their friends and followers that you are not a reliable site or application. In most cases, it doesn't make sense to fight and pay for getting more downloads of an app that represents little value and creates no reason for the user to get back to it after the initial use. The only effect you can get is to create more people who will be disappointed, delete the app, and never give you a second chance to make this first impression. Despite quite some evidence that the approach of driving more traffic and hoping to get results is not effective, still many companies put most of their marketing money into that area. However, it seems that some companies already found a better way. It seems that the most successful companies, instead of using pirate metrics to guide their focus, they are instead first focusing on fixing all possible leaks in their funnels and processes. Most often starting with elements related to the retention, making the metrics name rather hard to pronounce, RARRA. Retention is the area related to turning first-time users into repeating customers. It's pretty much everything that happens once customers already invested their time and effort to get to use an application for the first time. Then it starts to matter, does the application fulfill their needs and provide any value? Does it work as they, meaning customers, not developers, anticipate? But most importantly, will the second, third, and every next time the user run the application or visit the website, will it be providing them a similar value, gratification, and experience as the first use they ever had? Should you have only 10 customers, would they be willing and having any good reasons to keep returning to your system? If not, then maybe it's time to rethink the system first, before trying to drive more usage, more visitors, and more customers. Only after sorting out every possible issue and optimizing their retention, those companies start to look after the onboarding part, reflected by the activation metrics. That is not always about the order or payment itself, which might be part of the process, but it's covered in the revenue section as well. But activation is rather about the process that leads users from being the first-time visitors to becoming a customer. So this area is often referred or mixed with conversion rate optimization. But conversion rate optimization may be too narrow for many companies, as it is focusing on driving visitors to a desired action, like making a purchase, placing an order. While in activation, you shall in fact be thinking about the whole onboarding process of getting people to acquire and use your product or service, where of course the ordering or conversion rate optimization will be only a part. Then, after making sure that activation and retention are top-notch, successful growth hackers are looking for ways to make their customers so excited about the product or service that they will be willing to spread the message among their friends and online followers. Note that those growth hackers are never burning any marketing money on new visitors until they are 100% sure that everything else is ready. Interestingly, if they made a good job in those previous steps, it may often not even be needed for the company to pay for marketing and for acquisition of new customers, as the above steps might be already producing a healthy inflow of interested visitors referred by friends and influencers. There are many examples of startups that reach thousands or even millions of users without spending any money on advertising or other costly traffic generation methods and tools. To make it possible to get there, companies need to have tools for measuring, monitoring, and analyzing every aspect of their applications and websites. While most, and you probably as well, already have a web analytics solution for analyzing the acquisition-related metrics, you might still need to implement a tool for optimizing the remaining parts of activation, revenue, and retention by monitoring the details of the site usage from the user's point of view. And this is where I would like to introduce to you IBM Tealeaf, which is a dedicated solution for capturing everything what a user see and do on a website. All information from the screen, exactly as presented to the users, are captured. All their clicks, interaction, text inputs, scrolling, and any other behaviors in the application or on the website are monitored, stored, and available for your analysis. Based on all that data, which is pretty much everything what happens in the application, you can define metrics and reports to monitor any kind of KPIs related to the usage of your solution. Once you identify areas that require optimization, you can then even replay each and every user's individual session to investigate the specific actions and how the application was responding to those actions. So what was the ultimate user experience? Based on this data, which was captured when the user was browsing your website or using your application. So this is a very accurate representation of what was presented and visible to the user. Then, once you have a tool, the key challenge is not to make reports or events which will be monitoring your website, but to know where to look to find value in this data. A common approach that you might see or know from many analytical tools is to define your metrics, KPIs, build reports, then aggregate those reports into dashboards, dozens of dashboards, which is actually producing lots of places where you might want to look for information. This may lead analysts to either spending most of their time on checking every dashboard and report during the day, or what might also be not so good, that they will start to ignore some of those reports or dashboards which were created. In both cases, it might be very time-consuming and ineffective, or even impossible, to spot anomalies in the data which might have a significant meaning for your business. Probably nobody ever said we need more data. And similarly here, monitoring applications may also quickly become similar to swimming on an ocean of data. You never know which direction to look, where to steer, to spot and reach a piece of valuable information. Most often, it's very hard to predict upfront which metrics or parameters or dimension can expose something interesting. It might be obvious in hindsight, but at the time an analyst is defining their reports, their metrics, the observation criteria, it might be more like seeking an unknown. The best would be, of course, to analyze everything, but then it might rapidly become impossible to watch all the metrics, reports, and KPIs by a human, especially considering that it's not only about a single metric, but very often about the relationships between those different metrics which are monitored. And to help you with this monitoring part, IBM Tealeaf provides two important tools. One is alerts and the second is anomaly detection. You might already have a good understanding of how alerts work. It's probably the most widely used method for letting you know that something important is happening in systems. You can define a threshold for a minimum or maximum value for a metric or ratio of metrics, define the specific time window in which you want to make your observations, and system will send you alerts. For example, when it will observe more than 100 cases of search with no results per 10 minutes, or maybe if there will be a drop in the conversion rate below 10% within the last hour. The key advantage of alerts is that they might be evaluated even every 5 minutes, providing you a very quick notification about things that might require your attention in the system right here and right now. Notification about alerts might be delivered to you over an email or sent to a dedicated Slack channel, depending on your preference. However, alerts are not a universal answer. They are not always the best solution, especially if you expect some fluctuations and seasonality in the normal behavior of your metrics. For cases when a metric may be behaving differently on different days, for example staying very low over the week and getting much higher values on weekends, it might be very difficult or even impossible to define a meaningful threshold for an alert, which will let the system know when it shall send you information that something is wrong. Another example might be related to an affiliate partner or social media influencer. If they will be posting new articles on their site once a week, that will create a very regular pattern on the traffic referred by their site, with peaks on the days when the new content is posted and then going down over time until the next publication time. Creating static thresholds for alert in such situations would be next to impossible. In such situations, we introduced an AI-powered anomaly detection mechanism, which can be of a great help supporting your daily work. It learns traffic patterns over time, detects seasonality, takes into consideration holidays, and builds a mathematical model for expected flow and normal variation of a selected metric. That you can see as a green channel visible on the chart. The blue line is the actual metric that is monitored. Data is evaluated daily, and whenever the metric value falls outside of the range which is expected, an alert is triggered. Those of you already using Tealeaf may know that knowing from an email alert that a specific metric is behaving in an unexpected way is only the start to the investigation about what is happening. You still need to understand what is causing such anomalies. And here there is another element in the anomaly detection tools, which is allowing you to analyze them and figure out what they may have in common. What are the correlated metrics and dimensions across the system to the anomaly which was detected. That's on this screenshot. Once an anomaly is detected, Tealeaf would analyze all dimensions across all metrics in your system to pinpoint those of them that exhibit correlation with the anomaly, so they are behaving in a similar way. Of course, correlation does not immediately mean causality. However, in many cases it would be very helpful to understand what is correlated and what is not correlated. For example, knowing that a new released version of a specific browser is closely correlated to the increase of checkout errors might drive your investigation of root causes into the right direction very quickly. To summarize, anomaly detection is a set of powerful machine learning algorithms that will be discussed on the following slides, that are used to learn what is normal, dynamically create alerting thresholds to let you know about any deviations, and probably the most important, provide you analysis of which other metrics dimensions are correlated to the observed anomaly, speeding up the investigation of the anomaly source. Without going too far into the depths of the mathematical models, you may want to know that for the forecasting of the expected data points of your metrics, IBM Tealeaf is using the Holt-Winter method, also known as exponential smoothing. When looking for anomalies, the algorithm takes into consideration trends and seasonality in data, as well as provided list of holidays. Holidays here are days on which we expect some unusual behavior, hence shall be ignored in the analysis. You might want to know that the list of holidays is unique for each organization hosted on IBM Tealeaf, hence it might reflect not only public holidays in a specific country, but also any other events like expected promotions, system updates, and anything else what might and is expected to affect the normal characteristics of the data. Once an anomaly is detected, Tealeaf is performing contribution analysis. That is a two-step process. First, the system is measuring correlation using the Kramer's v-test statistic. The engine is calculating the association between the metrics values and all dimensions selected for the contribution analysis. Second, using the Pearson's residual, it measures the association between the anomalous metric and each dimension item, pointing out those metrics that are mostly correlated to the observed anomaly. One word of caution here: when configuring anomaly detection on a metric, you need to make sure to exclude from the correlation analysis all metrics that are naturally and closely correlated to this metric. Like, for example, number of sessions will mostly be correlated to the number of page views. Number of orders will be correlated to the number of shopping carts. If you won't exclude them, they will always appear as the most correlated factors, hiding the more important correlations from your site. Of course, this is all configurable, so shall this happen, you can always remove unwanted dimensions from the analysis. Let's get to a demo of how anomaly detection may be used to accelerate your analysis. In this demo, you will see how anomaly detection can notify you about unexpected changes in a metric, and how you can use contribution analysis to investigate what is causing those anomalies. So let's assume that now you are a web analyst working for an online retailer. Most of the traffic to their site is generated through cooperation with affiliates and influencers, who are generating content and directing their followers to the company's site using affiliate links. For the company, it is important to track sources of the traffic for the purpose of commission payments, but also they are looking for any spikes in traffic from their partners that might be indicating which specific promotions and marketing activities are most successful, so they can accelerate them by additional actions, for example, reposting a partner's post or boosting the message using paid advertisement on social media. System, you already created several reports to track the traffic to the site and the most important metrics. One day you received an email alert from the Anomaly Detection engine informing you that an unusual traffic pattern was detected. In that case, the observed number of sessions was exceeding the expected value more than twice. Of course, in other scenarios you might be getting alerts when the number of sessions is dropping below the calculated range of expected values. When you open the console of IBM Tealeaf, you will immediately see there is a spike in the number of sessions within the last few days. Then you can navigate into the Analytics workspace, where you will be able to investigate the situation further. Reports on which anomaly detection is enabled are marked with a blue triangle in the top left corner that is also acting as a switch to get the report to the anomaly detection view. In that view, you will see a green area that is reflecting how the system is predicting ranges of expected values for each day, and red marks highlighting days when an anomaly was detected. Note that at this time anomalies are calculated daily, so every data point here represents a full day of data. Also, as the anomaly detection engine requires quite some data to understand what is normal, only metrics that were correcting data for at least 14 days are considered. For each detected anomaly, you can click on it and open the list of so-called contributing factors. The list is showing you which dimensions on the other metrics are most correlated to the anomaly in the metric which you are analyzing. That means that the system is making a ranking of dimensions on which it is observing similar changes as on the metric in the report. In our example, the system detected that the factor strongly correlated with the increase of the total number of sessions is a specific traffic source, here partner DDD, and a specific promotion called Super Promo. Looking on how the demo system was configured, this is exactly what happened, as on the day of the anomaly we were injecting into the system twice as many sessions, and all of those additional sessions were coming from that particular partner and were labeled with this specific promotion. In a similar way, anomaly detection and the analysis of contributing factors may help you detect that, for example, the increase in the number of errors is correlated to a new version of a popular browser. Going back to the reporting workspace, you can notice that not only the traffic is increased, but also that there was an increase in the number of abandoned shopping carts, as well as a slight increase in the abandonment rate. In many cases, a web analyst can simply assume that when they have twice as many visitors, they may expect to have twice as many abandoned shopping carts, and leave that as it is. However, that might require further investigation. In the end, customers seem to be very interested in that super promo, hence it would be more logical to see a decrease in the abandonment rate. So it might be good to double check if there might be something unusual preventing your new customers from placing their orders. Now we are repeating a similar scenario on the abandoned carts report, opening the report in the anomaly detection view and reviewing the list of contributing factors. Of course, the top contributing factors are the same as those related to the increase in traffic. However, you might be able to notice something else, that the increase in abandoned carts is not only correlated to the new traffic and the specific promo and traffic source, but also to the number of people using Linux. And that is not necessarily normal. So let's investigate further and use the capability provided by Tealeaf to dig from the macro view to micro details of each session and run the session replay. Directly from the list of correlated factors, you can jump to the list of all sessions that had that specific combination of dimension values. There you can open session replay that is using the exact same information as was presented to the specific user on their screen during their session, what lets you visually inspect what happened during the session and what prevented people from actually placing the order. In this scenario, you will find out that all Linux users were facing an error when they were trying to add products to the shopping cart. Note that in our event tracking the shopping cart abandonment, we configured this in a way to detect the attempt of adding a product, clicking on Add to Cart button as a starting point for the abandonment event. This provided us a much better sensitivity of detection if something was wrong, comparing to many other tools that only track cart abandonment from the moment when items are already in the shopping cart. Concludes the presentation and the demo. I hope it provided you good understanding on how Anomaly Detection and IBM Tealeaf can accelerate your business by providing you necessary means to refocus your website and mobile application monitoring on the aspects that are driving the most value for successful startups incorporating growth hacking strategies. Thank you for your attention.